My son has been helping me prepare presentations, and when he was younger, it focused on clip art, so I had Power Rangers and Transformers in it. Now he's concerned about popular references, so replication and economics turned into this. Might be too soon for some people. Okay. So this is joint with Hoskin Galliani at Maryland and Mauricio Romero at UC San Diego, with large inputs from Sarah White, who used to staff BITS and other people in SIGA. So we're going to be talking about replication, and I want to really focus in on, so let me be clear on a specific type of replication we're going to focus on. We're going to focus on code replication. So the idea that we want to replicate a study's code using the same data in a paper to assess whether the code reproduced the results in the paper. We're not going to be looking at what we call reanalysis. We don't think of that as replication. Reanalysis of the data under alternative sample, variable construction, and specification. Nor are we going to be looking at study replication, which is using data from a different population to study the same questions in the same way. So what do we mean by code replication? Again, it's using data previously studied. We want to verify that the code was correct and that there are no errors. And we seek only to replicate the analyses done by the original authors. This type of replication, if done, or at least there's the threat of it, should reduce the incentive for authors to misreport, or that's the political term, lie is the technical term. Incentives for authors also to put in a lot of effort to make sure the code is correct as possible. So you can get misreporting either because of cheating or just because of author being sloppy. So what does this involve? It involves, one, taking the raw data, reconstructing the sample used in the analysis, reconstructing the variables from the raw data, confirm that the analysis code reproduces the reported results, and in this sense, the results can be thought of as replicated, or the code replication. We're not going to look at reanalysis of data. That's what I said. This is not a replication. We don't address that here. And we don't address the replication for using data for external validity from another population. Okay. So we wanted to develop a framework for how we should think about that. What's a system? What's a successful system or environment for this code replication to really achieve its objective of increasing our confidence that the knowledge generated is correct and providing these good incentives for good researcher behavior. And we came up with kind of three criteria. One is that the incentive structure for the person doing the replication, that it's unbiased. In particular, we're going to focus on the incentive to overturn or to find or claim mistakes in the original analysis. And a good portion of what we're going to do focuses on this. We're going to present some evidence where we think this is true. And then in the back end, we're going to propose a different way, a different environment, and a different structure for doing replication, which we think mitigates overturn bias. We would like it to be fair. We'd like to have all probabilities of either being replicated or having some probability of being replicated, right? That's where you can think of replication as like an IRS audit. You behave better just under it's not the actual audit that matters, it's the threat of audit that matters. We'd like the sample of papers to be somewhat representative. In that sense, we don't want to target particular authors, we don't want to target particular topics, or we don't want to target results. In this sense, we don't want to just choose papers that are thought to be important. And then we'd like it to be efficient in the sense that we'd like to provide these incentives, but really like to do it at low cost, right? And so now you can tell I'm an economist since I put efficient down at the bottom. Okay, sorry. There's a truth in advertising here, or an acknowledgement, which is this paper came out of Irritation by Sebastian Galliani and I having a paper replicated. And we found the process was completely distasteful, expensive in terms of our time, and irritation in terms of with the replicators, even though at the end of the process, they didn't find anything that disputed what we had. It was very costly to us. And the incentive for us to participate in this, again, is really, really low. Okay. So what are the incentives to replicate? Well, we'd like trained researchers to conduct this replication study. So you'd like people who have some background, who know the methods that you're involved in. One of the big costs is getting the original data in the code. Now, in economics and political science, journals now, the majority of journals now are requiring you to post your code and data pre-publication. Some of that's going on in sociology and psychology as well, but they tend to be a little bit behind in terms of doing that. What we'll show in this study, like a lot of other studies, that even though it's posted, it's almost impossible to use. And at least in the 200-some papers we looked at across 11 top economics journals, we could actually really only replicate 13% of the papers we looked at out of 200. That includes starting from the raw data all the way through. So that the availability of data, while it's good policy, isn't yet working. We think of, when we look at researchers, we think of the payoff to doing replication, to being a replicator, is the tremendous goodwill and that you get from the profession, the appreciation of all your other, of the community that we all value, plus the fact that you might be able to publish an article out of this. So it's the, so we're thinking of the return is publication. And that leads to this overturn bias. We're going to show some evidence where we not only look at the journals to see how many replications were published, but we actually surveyed journal editors in top journals in the 4 disciplines. And we find, while there's a preference or there's a willingness to consider replications for publications that overturn major results, there's substantially less and almost no interest in publishing papers that confirm results. So if you're going to get into this business, you spend all this time and effort, and there's very little chance that you can publish it if you confirm, you're going to work damn hard to find a problem. Okay. And so that's one of the things we want to solve. Okay. All right, so let's start out with incentives to replicate, get at this overturn bias. So we surveyed editors from top journals in economics, political science, sociology, and psychology. These are not all top journals. They're the top journals that we could get a few people in each discipline to agree to. And as soon as we presented the list to someone else, that top list, so this is a top list, not the top list, as David Letterman would say. Now, it was an online survey with 6 yes or no questions. So this was not a lot of work. Response rates were remarkably low given how easy this was. We tried to get all editors from these journals, from these 39 journals, that have decision-making power. So we didn't take associate editors, but in economics it's common to have many co-editors who have a decision of accept or reject. So we took anyone who had that. So we got 39 editors, we got 61 editors out of 200 surveyed, representing 28 of the 39 surveys. And we're just going to show you the response to these 2 questions. Would you consider publishing a replication study, and we defined replication, of a paper previously published in your journal if it claims to overturn, confirm the results of the original paper? Here are the response rates. So in economics, we surveyed 11 journals. We got at least 1 editor responding from those 11 journals. In political science, we surveyed 10. We got at least 1 editor from 8 of those. In psychology and sociology, we couldn't even get 1 out of half of the journals that we tried to survey. And that indicates, I think, in part where those disciplines are in terms of replication. These are the answers. The share that say they would publish a replication study, blue if overturned, and red if it confirms. So in economics, we really like to eat our young. So if you can find a mistake in someone's paper, we'll publish it and put it right up there. But if you confirm, only about 30%, 29% said they would even consider it. In political science, there's a high rate of saying they would overturn, or sorry, they would publish if it overturns, but half of those surveyed said they would publish even if confirmed. So there seems to be somewhat of a more open attitude. The psychology and sociology numbers look high, but remember, we only have half the journals represented. So if you were to re-rate these, say, assuming that the people didn't respond, didn't care about replication, those numbers would be half those sizes. So I have to figure out a better way to present these numbers, but last night, when we were putting this stuff together, this seemed to be the most convenient way. Okay, now in economics, we looked at how many replication studies, including reanalysis, have been published in these top 11 economics journals in the last 5 years. So we could find 8 in those journals, and then we supplemented our data with 2 more, which we knew about, but the replications were published either in other disciplines or in substantially lower ranked journals that we wouldn't come them a lot. So it's not that 8 studies only have been published, it just tells you what the top journals are thinking. More are published of papers in top journals in lower ranked journals, and hence they get much less visibility. All of the studies published we looked at claim to overturn the original results. And then we started looking at citation counts to the replication study and to the original articles to see if we could find some break in the trend of citations. And there's no consistent punishment of papers when you have replication studies claiming to overturn. We find some seem to flatten, but others go up. And I'll just show you some of the data. So these are 6 of the 10. This line, which I think is probably invisible to you, is where the replication occurred. So the replication here, well, it occurs in 2013. And you can see, even though the replication was cited well, there's no change in the trend of citation of that paper. This was always flat. This is Miguel and Kramer, and it does look like there might be some break in terms of citation counts. This is one again where there might be a break. Here there's no break. Here this flattened well before the public before it. And here are 4 more. Here there could be some flattening. Here there definitely was. This is taxes and cigarettes consumption. Here there's none. This is a climate change paper. And here there was none as well. Now, we had planned on doing statistical analysis of this with the hundreds of replication studies we expected to find. But since we could only find 8 or 10, we just displayed the data rather than trying to say something statistical about this. But it's not consistently saying that if someone replicates you and they claim you're wrong, that the paper no longer is influential. It happens in a few cases, it doesn't happen in other cases. Okay, so that's the environment. We don't publish replications that confirm, we only punish them that overturn. We don't publish many of them. Now that could be because not a lot of them are produced, right? We don't have a sample which says how many replication studies are there out there and what's the probability of it actually getting accepted. That's data we'd like, and I'll actually show you some of that data later on. So that's the first piece. The incentives seem to be towards overturn bias and a hard probability of getting published, no cost or little cost to authors. Now let's focus on some of the costs of doing code replication. The big thing is getting the original data in code, but also having access to the original authors to answer questions understand the data, and why did they do things? Are there things that they did that weren't in the code? So for example, in economics, the major publication for us is actually not in a journal. We get it out in working paper series. So if you're in the National Bureau of Economic Research, working paper series, half the citations to your paper end up coming from those, because it takes us about 8 years from the time we put out a working paper to actually get it in print. So, so in lots of these cases, a lot of the extra analyses or variable construction are described in the working paper, but don't end up in the final article because editors don't want it, it's too long, things like that. And then the replicators discover this stuff in an aha moment, but if you don't know where the working paper was, you can't come back and talk about that. So it's important that the replicators and the original authors have some sort of working relationship. Now, in reanalysis, there is a lot of judgment calls. You're basically saying the original author who used a linear variable was an idiot, it should really be a log, and when you do a log, it's much better, and I thought of that, that was my judgment. Now, economics, along with political science, it turns out, have made an advance where it's become the norm for journals to require you to post your data and code pre-publication. Okay, and I'll show you, at least in the journals we looked at. And so we're going to look at these data, and we're going to do something that a number of other authors have already done, but we're going to do it systematically in economics over more journals, is we're going to look at how many articles actually post their data and code prior to publication, even though it's a requirement. How much of that, how many post the raw data as opposed to just the final analysis file? How many do you get the code to run on the raw data to produce the sample? How many do you get of the analysis actually produce the table? And then how many of those actually replicate studies? So we looked at, all right. So we looked at 11 economics journals. I used to have a slide as to what they were. I do later, okay. So here are, what we did was we went on the journal websites and just asked what are the journal policies. So we took top tier economics, again this is a top tier, and of the 11 journals, 10 said they are required to post data and code before publication. One didn't require it but encouraged it. All 10 said the raw data must be submitted, not just the analysis data. None of them verify that this actually happens, right? So this is, these are like the new EPA regulations, comply if you want. In the mid-tier journals, though, the bottom 23, there's much less of this. Only about half of them require, or less than half, 8 out of 23, whatever that turns out to be, a third. 9 suggest it, only 7 out of the 8 require, and none confirm. And in political science, in the 10 journals we looked at, 8 required, and what is really interesting in political science is 3 of those actually went and verified. And so that's the only place we could find that is quite important. Sociology and psychology, we couldn't find anything on websites except in a couple journals that say you're required to post. Okay. All right, so now we're going to do this push button exercise that I talked about in economics. We're just going to take those top 11 journals, actually it turned out to be 9 in the end, where the last 3 issues in 2000, I guess it was all 2016, it might have been 2016 and the first in 2015. We looked at 415 articles. We selected non-structural empirical papers. So in economics, well, I'll just say in economics, there's a body of empirical work which is very functional form related, and we didn't want to do that. It was very hard. We didn't do theory papers. We found 266 articles out of the 415 eligible, and when we looked at them, 63 said they use restricted or proprietary data that they were not allowed to make public. Okay. So we had a final sample of about half of those where we could try the replication analysis. Here are the journals. Okay, so these are the share of studies with posted data and code. So 3/4 of the papers that were required to post their data and code, only 3 of the journals, only 3/4 of them actually did. So we had about a quarter published without any data or code. Only 32% reported the raw data. Now 42% reported the data code and reported the data code. Well, that's because those that had restricted data also reported their code in case you could somehow come up with a couple $100,000 to get the restricted data. And the same with the estimation data and the estimation code. Now here's the execution of that. So the blue is conditional on having the data in the code, how much executed. The red is unconditional over the 203. So about half that we had the raw data we were able to execute, and that's about 16% of all studies. The estimation code, similar results, but the code ran. Now remember, we had more estimation data than we had raw data. And go to the last one. These are the studies with both raw data, the data code, the estimation, and the estimation code. So this is, you've posted everything. 97% of those ran and replicated the tables. But that's only 14% of the whole sample. So only 14% met the criteria that we wanted. All right. And this is very similar to things that have been found in the other literature. I'm not going to go through this. You're all speed readers, but if your paper's not up there, I apologize. Okay, so what have we learned so far? The cost of replication is high due to low access to data, and we want to improve data availability. And here are some recommendations for editors to do that. I do want to spend a couple minutes on an unusual experience, an unusual body of data for this. So the International Initiative for Impact Evaluation got some money to commission replication studies of important papers in development that were done in low and middle income countries. And the goal was to bring more people into doing replication because there wasn't enough replication being done and based on some group of people. The goal was to generate more high quality replication. 3IE identified initially a set of papers they thought were important. And these were a pool that they wanted other people to go replicate. They invited proposals. You could get a $30,000 grant. And then they developed really good rules of engagement with the authors, which is, you have to tell the author, you have to tell them how nice you are, you have to promise to run every result by them before you make it public, you have to promise to, play nice in the sandbox so that the authors don't feel threatened and we get a good result. And then they posted the completed studies on their website and the 23 studies in total. In fact, when this thing started, I was on the board of directors of 3IE, and it seemed like a really interesting project that we could learn a lot from. And you'll see that a lot of things went wrong in our view. Okay, so what's nice about this again is this is a sample of replication studies that were started. So we can see how many replication studies never got finished, how many were done but never got published, and then how many got published. So, because what I've shown you up till now is really just data on published studies. All right, so here are the status of the 3IE Replication Study Awards. They awarded 27. 14 of them went to papers published in economics journals, and 13 were for replication of articles that were in medical or health journals. 5 of the 14 in economics were never completed. They have a status of canceled. So we don't know why they were canceled. We're going to try and figure that out. This was because the authors were uncooperative, the replicators weren't very good or motivated or what. But all of the ones in medical journals were completed. 2 of them are ongoing, and we have 9 completed economics and 11 completed medical ones. Okay, so these are the share of completed 3IE replication studies that say they replicate the original results. Almost all of them in economics, and close to half in the medical journals, and overall about 65%. Now, okay, so that seems pretty good, right? As far as I know, only one of those studies has ended up in a journal, okay, the replication of TED study. And then it turns out when you look at the reports written by the original authors, there were also comments on those reports by the original authors. And this tells you something about the relationship and what the authors thought of it. So this paper about this Stephen Durkheim paper, the statement that our original conclusions were robust was buried in the text with no mention of this either in the abstract or the conclusion. Instead, emphasis was placed on the statements that our finding on agricultural extension were not robust. On Jensen and Oster, despite the way the authors have stated their findings, the conclusions of our paper remain clear and unchanged. Cameron et al. Even though we disagree with the unnecessarily aggressive tone of some statements in the replication report, particularly in the abstract, we focus only on those comments that could be misleading to readers. And then this is my paper by Matias Catano. Despite having informed the replicators about this, we find this added comment in the abstract of the replication report inaccurate, inappropriate, and arguably misleading to the readers of the report, something that we had hoped to correct with this added section to our original response to the replicators. And then finally, on the worms, the famous Worms War paper, which was replicated, I'm just going to read some statements by some of the blogs that came out of this. So this is Michael and Ted's response. The second paper is a reanalysis that makes a series of analytic errors, many of which were on counter to their own pre-analysis plan. And we have evidence in correspondence that this was communicated to the authors prior to publication. Givewell. While we think that replicating and challenging studies is a good thing, it looks in the case where there was an aggressive media push. In our view, the best reason to be skeptical about the evidence for deworming pertained to external validity. Chris Blattman's comment. Whether it's a sensational photo, a sensational result, or a sensational takedown of a seminal paper, everybody has incentive to exaggerate. This whole episode makes a sorry day for science. And then action aid. Unfortunately, what aid can do statistically is not best practice. They chop up the data into smaller subsamples. They include data on kids before deworming starts and the deworming treatment. No surprise, the choices, which your Stats 101 professor would counsel against, make the key result weaker. And so there was a paper published basically claiming to overturn the worms results. It was picked up by the press, leading to donors not to want to, or at least press that donors shouldn't fund this. And the scientific analysis of this was there were problems, and that was communicated to the authors ahead of time. But the pressure to get a novel result, to get it out and get notoriety here, we think overwhelmed, and this is really this overturn bias. Now, for me, what this says is, and I have to say, I found the whole experience unpleasant. And part of it has to do with who are we bringing in to do the replications. Not that these people aren't well-meaning. The original authors are mostly professors at top institutions with a median citation count of over 4,000. The replicators were professor, PhD students, only a couple of which had citations. And so when you have this relationship between replicators and original authors, it's necessarily adversarial. I'm, as a replicator, trying to overturn your results because that's my return. Two, who's checking that the replication was done right? The code of the replication was done right. So we had this problem in our replication where we had a PhD student. We had a non-stated driven piece of this, which was basically a multi-indicator matching procedure that we had to write from scratch and was out of a journal. She didn't understand that. We had to teach her how to do that. Okay, and there are many errors along the way. So we came back, we found it to be a large amount of time in terms of making sure the replicators were accurate. And I think the example from the Worms paper is even when you inform the replicators prior to publication, they don't necessarily include that, and there's no recourse. Okay, so I'm going to take a minute and a half more, Garrett. So, and since you can't say anything, I'll thank you for that. Right, okay. Right now we have little incentive to do replication, huge overturn bias, and little incentive for original authors really to cooperate. A lot of the 3IE authors said they would never participate in this again. So we have a proposal. The journals should really conduct the code replication pre-publication. Pre-publication, authors have a huge incentive to cooperate with the journal and make sure it's right. It's one of the few times you can actually get their attention. The journal should verify that all data and raw analysis files are posted, they execute and produce the paper, and then randomly select a subsample to reconstruct code. So they take the data, the methods of the authors, and try and reproduce the results using new code. They iterate with the authors till they agree. If the results change, then the editors can choose to ignore it or re-review the paper, so there's strong incentives. And this is a very strong incentive not to misreport or not put effort into the code. It's not that we're going to do this for every article, but a random sample. That provides very good properties. It's unbiased. There's no overturn bias. In journal editors we trust. It's fair in the sense that all papers have a probability of being replicated, and it's low cost. Authors have incentive to cooperate pre-publication. And since I'm doing it with a journal, with someone, with say an employee of the journal, an RA, they have no incentive to overturn. So there's going to be a lot less animosity and irritation. And this, I think, provides the incentives that we want. So thank you for putting up with my, my overrun. This is all an attempt to make replication great again.
Yes, some questions. Over there.
I know, that was the same with America.
So I was just wondering about when you were doing just kind of the basic code replication, were you keeping track of, is it in Stata, R, Python, etc.? I've had times where I was trying to replicate something and it was in Fortran, and I was like, well, you made the decision for me.
Yeah, don't try and replicate my thesis, because I was that way in the last millennium. But no, it's most of the stuff we looked at in economics journals were in Stata. R is being more popular. We didn't see anything in Python. We have those data. Oh, sorry. All right, following rules again.
So I was wondering, it seems to me that checking of the code and checking of the analysis shouldn't really be done by the journal, it should be done by the peer reviewer. Whereas if I submit a paper and at the same time I submit my codes, then the reviewer should go through that code and check if that's correct as well, just as they do with the paper, right? That makes more sense than doing it after the peer review process, and then if it's not correct, going back to peer review process. I think journals would have a lot of problems with the cost in that.
Well, I think it then raises dramatically the cost to reviewers. We have enough. So I talked about this with editors, and we first talked about it. Editors say, I can barely get reviewers to deliver on time in economics. There's no way I can get them to actually look at the code. So this came out of a discussion with that, one, we don't have to check the code of every paper. We only have to threaten to. And that, basically what I did, we did this exercise. We hired a quarter-time RA for a semester to do this for 200 papers. So it's not very expensive. And it's, someone's going to pay one way or another. I suspect that it's going to more likely to be done if it's somehow managed by the editors rather than the reviewers. But it's an equally plausible thing to do. But again, it takes it out of the, both methods take this adversarial relationship away.
Thank you for the good presentation. I have, maybe it's not really a question, but it's just a reflection. So in the replication, what are we looking at? Are we looking at just the code and the result, or are we looking also at the problems of implementation? So an example is, for instance, let's say that I'm doing an analysis and I'm using a data set using a complex survey design, okay? So if I just take the code and run the analysis, I will get the result, they publish the result. But is that true? Because there is a problem of implementation because the authors didn't take into account the complex survey design. So I don't know where we are. And then not really a question, but it's just a reflection again. So in terms of data, making available data. So my thinking is what are, for instance, the responsibilities of national statistics offices? Yeah, because for instance, in Canada, researchers working with confidential microdata produced by StatCan, in any form, the data cannot go out. So how do the researchers, even though they are willing to make the data set public, but based on Statistics Act, for instance, they are not allowed to do that. So what are the reflections of researchers in this room?
Well, let me just say two quick things on that. One is, in economics, we publish a lot of papers with non-public data, restricted data. A good example is we use data from the US government, from tax forms or Social Security records, which cannot be made public by law. But we establish centers by which you can go in and run analyses. So in economics, what happens is we ask you to state before you submit, is this restricted data or not, and ask for an exemption. And if it is, you describe procedures by which another researcher could get access to those data. And then the editor makes a decision or not whether to go through with the review. In terms of field work, I'd say in economics of empirical papers, 75% or 80% are reanalysis of existing data. So it's less of a problem. But reviewers will want to see information on how you sampled, if you have your own work, how you did randomization, the methodological protocols. So I don't think we're going to ask researchers to go to your country or your field site and make sure you implemented them correctly. That's a lot harder and more expensive. But I think those types of things are subject to the normal review process.
All right, we're out of time, so we'll just have Ed ask this final question.
Can you tell us something about where the problems occur? There was a day and age where there was a unstructured, unrecorded system of going from original data set into something that you're going to actually study.
Yeah.
And I would have thought there'd be a lot of slippage with regard to that.
Yeah.
But once you get to that, I think you're calling the raw data
Yes.
was the beginning, and then you get to some intermediate point.
Yes.
You're expecting code to be provided that describes how the data set is reduced from the raw data to the final
Exactly.
data.
Whatever your original data source was, if you collected yourself or it was the NLSY that you downloaded from a website, I start with this data set. How do I select my sample, construct my variables, clean the data for a data set that I'll use to do estimation on?
So if I just think, it seems to me if you have that data set that is fed through some kind of R code or Stata, it's astounding to me that you don't get you can't replicate it. It was a time when computers doing a matrix inverse, near singular matrix inverse, would give you different conclusions depending upon what operating system you were working on. That doesn't seem to be a big issue now. So where's the problem coming from?
Well, I think we worry about two things. One is you're sloppy in going from your table, from your code to what you produce as a table. Or you have an RA do it who's new and you don't check it. Or it doesn't look right and you change the numbers a little bit. Those are the two things we're worried about. Now we find less problems. So our problem here is not that code doesn't, if you have that code and you have the raw data, we do a pretty good job of replicating the raw data tables. But we only get those raw data, that source data, in about a third of the cases. And even if you have the estimation code, here's a lot of the problems. Both the code to transform the data and the estimation code won't run. So they post it, they have some note saying it's in Stata version whatever, you upload it, you upload the data, it doesn't run. So we spent up to 5 hours trying to make it run on a paper, and we couldn't do it. Now, we didn't recontact the authors to say, you may have had a slash in the wrong place or things like that, and that may have solved the problem. But those are the types of things.
Or it may be the Stata code changed, where they found an error in the code.
Again, supposedly they say what version of Stata write in the code. Sometimes it wasn't there, though. So a lot of these are just poorly documented. That's another big issue. All right.
All right,
Thanks
thanks,
very much.
everyone.